Okay, so for today, we're kind of starting off with writing chemical equations. So you do have a lesson here that if you haven't already gone through it, you need to make sure you go back and look through it and take notes because it does go through um, some of the different vocabulary and the symbols that you're going to see in your equations that you need to be able to recognize so that you're able to translate them. So when you load the lesson, and we're not going to go through the whole thing because I want us to get to working on some examples together. Um, but if you haven't gone through this, then yeah, you definitely need to go through it. Um, so it kind of does an introduction for what chemical equations are and sort of why we use them. And then as you go through here, it's going to introduce some symbols that you're going to see pop up in our equations, and you need to know kind of what they mean so that you know how to use them and how to recognize them, what they're for. And then it's going to talk about some other vocabulary, reactants, and products. We need to know those terms and sort of what they mean. And then it goes through the actual process of translating. If you're given a word sentence like this in blue, how do you translate it to the formula equation? And then after that, there is a kind of a summary page here that kind of goes through a lot of the different vocabulary and how equations are set up. And then on this third part, it's backwards. It goes through, if you're given a symbol, a chemical equation like this with symbols and formulas, how do we translate it into a sentence form, okay, and with descriptions. And then at the end, you have just sort of a little check on some different vocabulary, some terminology, some things that are used in the section. So then your assignment today is you're actually going to be writing some chemical equations. And so what you'll be doing is there are 10 of them. 7 of them you're given the sentence description and you have to translate it to the formula equation. And then the last 3 you're given the chemical equation with the symbols and the formulas, and you are translating it back to sort of the sentence description. So since this requires you guys to write things down, you're going to be using that Adobe Scan app, or if you have a different app that lets you scan files or scan images, that's fine as long as you can upload it as a PDF. Okay. And then you could either, if you want to print out the worksheet and complete the information on here and then scan that, or you could just do it on your own notebook paper. Just make sure that you number the problems and you do it neatly so that I can tell where each one is with the work and with the information. Okay. But either way, you'll end up uploading that PDF scan of your work to submit for today. Okay. So what we are going to do now, I'm going to switch over to the iPad. Sarema, I saw your question. We'll get to that when we're going over the examples here in just a little bit. So if it doesn't get answered after we go over examples, then let me know, okay? I'm sure the iPad. All right, so go into our assignment. Okay, so this is what your assignment looks like. So when you go through the lesson, it kind of walks you through step by step, but it does help to actually see it worked out so that you know what the process is. So what I'm going to do is I go through this, you're going to see me like highlight or circle or underline things, because when you're first starting out, that's what helps. What helps is sort of in identifying the information in your description so that you know what you're going to write in your chemical equation. So the first thing that you should do is identify what are your substances. So what are the elements or the compounds? What are the chemicals in your equation? So in this first one, if I read the whole sentence, it says aluminum metal reacts with oxygen in the air to produce a white solid aluminum oxide. Okay. So first thing I want to do, I want to go through and I want to identify what are all the chemicals, what are all the substances, because not everything in this sentence is a chemical. There's some extraneous words, okay? The first one that I encounter is right here, aluminum, okay? Aluminum, is that an element or a compound?
An element.
It is an element because it's just the name aluminum, so that's just an element from our periodic table, okay? if I keep going, aluminum metal reacts with the next chemical that I see is oxygen. And oxygen is also an element that's also on our periodic table. So it says aluminum metal reacts with oxygen. So we have two elements reacting together and in the air to produce a white solid aluminum oxide. So the next chemical that I encounter is at the very end here. It's aluminum oxide. Now, is that an element or a compound based on its name? What do you guys think?
It's a compound.
It's a compound because it's got the biggest clue that it's a compound is it's not just one name because all our elements are just going to be one name. Okay. So it is a compound. And then before I go to write its formula, I need to know which kind of compound it is. So this is why on Monday we reviewed the ionic, covalent, and acid stuff because based on which type it is, that's going to help you to figure out how to write the formula for that compound because they're all slightly different. So can anybody tell me just by looking at the name of this one, do you think it's ionic, covalent, or acid? What do we think?
I think it's ionic.
Okay, anybody else have an opinion or agree, disagree?
Ionic.
It is, yeah, it is ionic. Okay, the kind of the biggest indicators, number one, it doesn't have the word acid in it, so it cannot be an acid. Number two, it doesn't have any prefixes. I don't see like mono, di, tri, so it's not probably not covalent. But then also aluminum is a metal. And anytime you have a metal, that's automatically ionic. Okay. And so keep that in mind because you need to know what kind of compound it is so that when we go to write the formula, we know how to do it correctly. Okay. Say that again. So I said that we know it's not an acid because it doesn't have the word acid in the name, and it doesn't have any prefixes, so it's probably not. It can't be covalent because it would have prefixes. So it's got to be ionic, and then our other indicator that it's ionic is that aluminum is a metal. Okay, so it's got a metal in it, so it's ionic. Okay, so now I want to sort of translate these, or not translate, but I want to kind of write this in an equation form with the words. Okay. So I'm going to take aluminum. So I have aluminum. Now, it says right here that it says aluminum metal reacts with. Anytime it says reacts with, combines with, mixes. I'm trying to think if there's any other terms that we usually see. Reacts with, combines, mixes. Those are typically the most common you see, but anything like that, that's indicating that that is where my plus sign goes because I'm mixing them together, I'm reacting them together, so I'm having to add them together. Okay. Then after that we have oxygen. So I'm going to write oxygen. And then it says in the air, that's just kind of extraneous information. But then it says to produce. Anytime you see and it could be worded slightly differently. It might say to produce, or it might say produces. It might say yields, Y-I-E-L-D-S. It might say makes. It might say forms, or like to form or to make. But any sort of variation of that is where my arrow goes, because that's the arrow is telling me that's where my change is happening, because now we're going to make new substances. Okay. So then on the right side, this is where I list my any products. Now in this equation, or is this sentence, there's only one product. It's just that ionic compound. Okay. So the way that I go about this is I need to write the name that they give us here. So that would just be aluminum. Yeah, just making sure I spelled that right. Aluminum oxide. So just writing it in the form of equation with the words, this is what it should look like. Once you have it written in this form, then what you're going to do is translate all of your names into the chemical symbols and the formulas. Okay. So the elements are really easy. Okay, as long as you have your periodic table to look at, which you should. So if I can get mine to go, how much you want to go? There it goes. I'll go over to our reference chart. Okay, so I need to know symbols for aluminum and for oxygen. So what's the symbol for aluminum on here? You're ahead of us, Sarima. We'll get there. So right now, I just want to know the first reactant is just aluminum. So what's the symbol for aluminum? It is Al. Thank you, Camila. Thank you, Jose. Thank you, Sarima. All right, so it's Al. I can see it right here. It's in group 13. Okay. And then what's the symbol for oxygen? Okay, it's over here. It's O. Here's the catch. Okay, I'm going to switch back to the worksheet. Okay, here's the catch. Okay, aluminum is Al, correct? Okay, Al plus. Now I'm writing the formula equation spaced out so that it lines up with the name, the word equation. You don't have to do that. The formula equation, you can write it like, you know, close to each other. That doesn't have to be spread out. Oxygen, from the periodic table, it's O, but there's a catch with oxygen. Does anybody know what it is from the notes? If you've gone through the lesson, it's in the lesson already. So oxygen is, yes, it's the, Sarima is just correct. So oxygen is one of 7 elements that is they're kind of a special category. We call them diatomic molecules or diatomic elements. And what that means, if we kind of break down that word, di means 2, that's our prefix for 2, and atomic means atoms. And so literally what it means is in nature, these 7 elements do not exist as single atoms. They always exist as pairs of atoms of that element. And so anytime you see oxygen, or sometimes they might just say oxygen gas, they might describe it as oxygen gas. Anytime you see oxygen just by itself in its elemental form in a chemical reaction, it is always written like this. It's always got a 2 subscript because it's diatomic, and that means it's always going to be 2 atoms of oxygens together. Okay. There are 6 other elements that were on your lesson that you need to know those because they are going to pop up. And if you don't know them, you're going to write the equation incorrectly. And then on like Friday and next week, we're going to be balancing the equations. So we're going to start worrying about like the amounts of the atoms that are in our equations. And so if you don't write diatomics correctly, then your numbers are going to be wrong. And then your balancing is going to be wrong. And then later on, when we start doing math, then you're going to get the math wrong. And like, this is where like, it doesn't seem like that big a deal right now, but this is like, you know, if a number's off and somebody was like determining something for the space station, that could like kill people. Or if you're in a doctor and you're trying to figure out numbers for something, okay, for like dosages. So numbers are important, even though right now we're just doing practice in our high school chemistry class, okay? So O2 for oxygen, it always has to be like that. I'm gonna bring down my arrow, rewrite that. Now, here is what's probably gonna be the most difficult thing for you guys, is writing the formulas for the compounds, specifically the ionic compounds and probably the acids, okay? Covalent compounds are a lot easier because we just use the prefixes to tell us the subscripts in the formula. But the ionic and the acids, remember, we have to balance out charges. So when I need to write the formula for aluminum oxide, I need to know, okay, aluminum and oxygen on the periodic table, what charges do they have based on their location? And so if you need to go to your reference chart to look at your periodic table, if you guys remember, we talked about the fact that like group 1 is +1, group 2 is +2, and then we kind of skip all the transition metals. We come over here, group 13 is +3. Group 14, we don't really use a lot. It can be plus or -4. And then it goes backwards, -3, -2, -1, and then the noble gases are 0 because they already have a full shell of valence electrons. So you got to remember those charges for those groups because that's how you figure out that aluminum right here is +3 and oxygen over here is -2. Because what a lot of you guys are going to do, and this because this is what always happens, you guys forget about the charges and you just go, oh, aluminum oxide, that's ALO. Okay, you're like, I just put the symbols together. But you can't do that. You got to pay attention to your charges. Okay, that is wrong. Okay. So we just looked at the periodic table. We saw aluminum was in group 13, so it's 3 plus or plus 3. Oxygen is in group 16, which means it's minus 2. So now this is where you can either do kind of your math and balance out the charges, or you can crisscross. So if I do the crisscross, the 3 comes down here and becomes the subscript behind the oxygen. The 2 crosses down here and it becomes the subscript for the aluminum. So when I rewrite that, I get Al2O3. That is the correct formula for that ionic compound. So anytime you have ionic compounds, you still got to follow those rules about balancing their charges. You can't just write the symbols of the elements together, okay? Because once again, next time on Friday, we're going to start talking about balancing, because right now, the way that this equation is written, there's one aluminum atom here, but then over here, now there's 2 aluminum atoms. Like, how did that happen? Okay, because I can't create or destroy matter. So that means that right now, this equation is not balanced. Today, we're not worrying about balancing. We're going to talk about that on Friday. We're just worrying about writing the equations now. Roman numerals, if that's only if you have a transition metal and you use the Roman numerals in the name, not in the formulas. Okay, so there's one more thing. I'm gonna clean off this area a little bit. One more thing, we're not totally done yet. We need to include, not only do we talk about what is in the equation, but we need to include descriptions, okay? Because in our sentence, there are descriptions, and sometimes even if they don't give you the description in the sentence, you should still know what some of them are, okay? Because there are certain elements and compounds that are kind of common knowledge, okay? So on this one, up here in the sentence, it says aluminum metal, okay? So they're telling you aluminum is a metal. Even if they don't tell you aluminum is a metal, you should be able to look at the periodic table and know that it's a metal. And all metals at room temperature in their normal state, all metals are solid. There only is one exception. There's one metal that's a liquid at room temperature, and that is mercury. So since they say aluminum metal, I need to put the little state symbol for solid down here to indicate that my aluminum is in the solid state. So I put a little s, lowercase s in parentheses, and it's written small. It's written like a subscript, okay? It's not the same size as your element symbol. Now, the next one is oxygen. Now, they don't say, it doesn't say if it's what state oxygen is in, but oxygen is a pretty common element. You guys, I feel like y'all are smart enough, you can figure out what state is oxygen in at normal, like room temperature. What do we think? Oxygen's a liquid at room temperature? I would say it's a gas because we're breathing it, right? It goes in and out of our lungs, okay? So oxygen is going to be a gas, so you get a lowercase g in parentheses after the O2. And then the last one, they actually do give us a hint on this one. It says right here, it's a white solid. The white is just describing the color. There's no way for us to indicate the color in our chemical equation, but the state of matter we can. And so that solid, I would put an S here behind the Al2O3. Now I'm done, okay? So what you guys should be doing, what I should see in terms of like work on your assignment, I should see both of these. I should see the word equation. So just the words put into the format of the equation with the arrow and the plus signs. And then I should see that's translated into the symbol equation with the formulas written correctly and with your state symbols included, okay? If you need to go off to the side and do like work where you do the charges for like your ionic compounds and you cross them, that's fine. You can do that off to the side as long as I can neatly see your work like this for each one, okay? If you print this out and you want to highlight the stuff in the sentence or underline it, that's fine too. If you don't want to print it out, or if you're not able to print it out, if you want to, I mean, if you really want to write the sentences out so that you can go through that process of like highlighting, kind of like I did, or underlining, you can totally do that if that's going to help you. But if you don't think that you need to do that, then bare minimum is you need to make sure that you translate or write the words in the equation form first. And then once you have that equation set up, then you can translate it to the symbols and add in the state symbols. Okay. What I want to say really quick, there's a couple other vocabulary things that I want to clarify. Let me get rid of that really quick. So if we look here, like on number 2, it says when solid copper reacts with silver nitrate, and then it says dissolved in water. Okay. Dissolved in water, this is another like phrase that's going to pop up. And if you have gone through the notes on Canvas, you saw that if it says dissolved in water, that is, you use the state symbol AQ. Okay, so it's not a solid, it's not a liquid, it's not a gas. It's actually called an aqueous solution. And anytime you have an aqueous solution, it means that you took some substance and you dissolved it in water. So a lot of our chemical reactions involve aqueous solutions because normally ionic compounds like aluminum oxide up here, normally they're solid at room temperature. So if you think of like table salt, that's sodium chloride, okay? Baking soda, okay? Any kind of solid or ionic compound is always solid. And so usually we have to dissolve them in water to get them to be able to do a chemical reaction. And so a lot of times they'll say it'll either say dissolved in water, or it might use the words aqueous solution, or it might just say solution. Anytime you see something like that, that indicates that your state symbol should be the AQ. Okay. No, as long as it makes sense, makes sense in the way it's worded in the sentence. Yeah, and we're going to go through one like that too. He was just asking if you're going the other way from the formulas to the word sentence. It doesn't matter. So you can use dissolved in water, you can say solution or aqueous solution, as long as it makes sense in the like the way the sentence is written. Okay. Like this one, if I just replaced dissolved in water with aqueous, if I just said when solid copper reacts with silver nitrate aqueous solution, that doesn't make sense. You would put the aqueous solution first. You would say with an aqueous solution of silver nitrate. So depending on where you place it in the sentence, that really kind of determines which one that you would use. So as long as it flows and makes sense, you can use either one to describe it. Okay. And then it says the products are aqueous copper 2 nitrate and solid silver. So again, they're giving you those key terms to the state symbols. But sometimes they don't give you the state symbols or the descriptions. So when you look at your reference chart for elements, most all metals are solid except mercury. Mercury is a liquid. And then there's only one other element that's a liquid. So here's mercury. The other one is over here, it's bromine. So this periodic table, if you look up here, there's a key. If the symbol is italicized, then it's a gas at room temperature. If it's bolded, it's a solid. If it's outlined, it's a liquid. And so you only have 2 liquids, mercury and bromine. Most things are going to be solid because all the rest of the metals are solid. And then a few of the nonmetals are solid. You have some gases over here. So hydrogen is a gas. And then your other ones that are italicized, nitrogen, oxygen, fluorine, chlorine. And those are really the only gases because these are noble gases, but you're never going to see them in a reaction because they don't react. So really your gases are going to be hydrogen, nitrogen, oxygen, fluorine, and chlorine. Your liquids are bromine and mercury. Everything else on the periodic table is a solid, okay, for reactions. For compounds, unless it says it's dissolved in water, ionic compounds are always solid unless it says aqueous or dissolved in water or something like that in the description. The only other liquid that you're really going to see other than those 2 elements, other than possibly bromine or mercury, the only other common thing that's liquid is water, H2O. Water is typically always a liquid unless the description says something about it being water vapor, that would make it a gas, or unless it says it's like ice or solid, something like that, that would be obviously solid H2O. But typically water's a liquid, but it's pretty much one of the only pure liquids. Everything else that you think might be a liquid is probably an aqueous solution because it was something that started out solid and it had to be dissolved in water to get it to react. So read carefully because again, like here on number 3, This first word, methanol, that's not a compound we learned because that is actually an what we call an organic compound. So it's a whole different category of compounds from ionic and covalent and acid. And so organic compounds are only made of carbon and hydrogen, and then sometimes oxygen or a couple other elements. But they're mostly carbon and hydrogen. And so they have their own category for naming. And so since we don't learn organic compounds here in our 10th grade chemistry class, I gave you guys the formula for it. So it's CH3OH, okay? But carbon monoxide and hydrogen gas, those are things that we covered how to do their names and formulas. So you didn't get those, okay? Down here on the very last one where you're going from the formulas to the sentences, there's another organic one. So it says right here, it's CH4, and it tells you CH4 is called methane, okay? And so that's another organic compound that we don't learn about those in this class. Those are higher level things. Those are things that I teach in my IB class because those are like college level chemistry type things, okay? All right, so I'm gonna switch over because there's only 3 where you guys are gonna practice translating to the sentences. So I have a different equation, a different worksheet that we're gonna go over how to go from the formula to the sentence. So I'm gonna do number 2 on this one. And this worksheet is set up to where it doesn't have the state symbols. So I'm gonna write them in so that we have them. So KClO3 would be a solid, KCl would be a solid, and then this is O2, so that's gonna be a gas. So if you're given the formula equation with the state symbols and you're asked to translate it to a sentence, you're just basically doing your same process backwards. So usually you start with your description. So the first thing is the reactant, and it's got that S. So that tells me that it's a solid. So I would say solid, and then after that, I need to have the name of the substance. Solid what? Well, I need to look at this. KClO3, that's definitely a compound. It's not an element. Is it ionic, is it covalent, or is it acid? Because that's going to determine how I do the name. So what do you guys think looking at that formula, how it's written? Which category do we think it is? Anybody got a guess? So first thing that I think is on your flow chart is, does it start with, does it have a metal? Is there a metal in that compound? So this very first element, K, that is a metal, okay? So if you follow your flow chart, it can't be an acid because acids would always start with hydrogen. They would always start with H in the formula. And it has a metal, so that means it can't be covalent. So this means it has to be ionic. And specifically, it's going to be an ionic compound with one of those polyatomic ions. Because if I go back, if I go to my flow chart, so if I go to my flow chart, we said, is there a metal? Yes. Is it a transition metal? No. Potassium, if you look on your periodic table, it's not a transition metal. And then it says count the different elements. We had 3 or more because we have potassium, and then we have a chlorine, and then we have 3 oxygens. So that means it's going to be the name of the metal first, and then the name of the polyatomic ion. And then on these, since it's a polyatomic ion, we do not change the ending to IDE. So going back to this one, what element is K on the periodic table? Yeah, so Jose's here in class and he says potassium, Soremo says potassium. K is potassium, so I would say solid potassium, and then I need to know what is ClO3 because that's the polyatomic ion. So that's where you would look at your formula chart, that list of polyatomic ions, and make sure you look carefully because there's several different ones that have chlorine and oxygen. So you're looking for the one that's got chlorine and 3 oxygens, and that one is chlorate. So solid potassium chlorate, that's it. It can't be an acid because it doesn't have hydrogen. Okay, if it was like HClO3, then that would be chloric acid, yes. But since it's got potassium, it's just an ionic compound. So potassium chlorate. So solid potassium chlorate. Now, there's not another reactant. So we can't really say reacts with anything because it doesn't have anything to react with, because right after that symbol, we get the arrow, right? So this is a type of reaction, and we're going to learn types of reactions next week in more detail. But if you only have one reactant, but you have more than one product, that is called decomposition. So that means you're taking one compound and you're breaking it down, or you're decomposing it into more than one product. Okay. So what I would probably use in this instance, in the sentence, is I would say solid potassium chlorate. I would probably say something like decomposes. Or if you wanted to use something a little simpler, you could say breaks down. Okay. But decomposes, breaks down to produce, or you could say to form or to make or to yield. Any of those would work. So solid potassium chlorate decomposes to produce, because that's my arrow. And now I need to write the names and the descriptions for my products. So the first product up here is KCl. So it produces, and it's an S, so it produces, so to produce solid, and then K is still potassium, but now it's Cl, not ClO3. So this would be, it's still an ionic compound because it's still got that metal potassium in it. But now if I go back to my flow chart for the names, what's going to happen is I would say, no, it's not a transition metal, but instead of going here, now I would go here. It's only two elements. It's a metal and a non-metal. So I do the name of the metal first, that's the potassium, and then I name my non-metal second and change the ending to IDE. So now it's not potassium chlorate, it is potassium chloride. And I'm going to come down here because I'm running out of room over there. So potassium chloride, and then because I have a second product, so to produce solid potassium chloride, and then how would I write the last product? Oxygen, what? I would say oxygen gas. That tells me what state it's in. Okay. So when you're doing these, it is going to be like tedious at first because you have to go like step by step. You have to make sure that if you have a compound that you write the formula correctly. So if it's ionic, you should be looking up charges. If it's covalent, then you just use the prefixes. If it's acid, then you should be using the charges again to balance. And so using your formula chart, or your reference chart, and then those flow charts, they are there to help you. They're there to help you to kind of get through this process of translating these. Okay. So definitely